Good morning, this is your Stat Sensei, Mr. Spensei, and this morning we're going to be working on death packet problems for proportions 71 through 80. So in a random sample of 450 adults, 28% said that they felt their credit card debt is too high. So we know we have a p hat of equal to 0.28, and we also have a sample size of 450. With what degree of confidence can the pollster say that 28 plus or minus 4%? Okay. So we also know we have a margin of error equal to 0.04. So with what degree of confidence can pollster say that 28 plus or minus 4% of adults believe that their credit card debt is too high? So I'm going to approach this in a way that I think students will like it. So this is not my preferred method. So N equals, and then we are going to have our formula Z star times, Z star squared, excuse me, times P times 1 minus P, or P hat, I should say, over margin of error squared. So Z star squared, P hat times 1 minus P hat. So let's plug in what we have. Well, we know the sample size is 450, and that's going to equal, well, we don't know what Z star is. I'm going to square it. But we know that P hat is 0.28. And if I take 1 minus 0.28, I end up getting 0.72. And we know our margin of error is 0.04. So let's do a little bit of math work here. I'm going to pause this for a moment to get rid of this glare. Hopefully that got rid of that glare or makes it a little bit better. So we're going to just multiply that. Oh, and I forgot this part has to be squared. 0.28 times 0.72. So 0.28 times the 0.72 divided by 0.04 raised to the second power. And that gives me 126. So 450 equals Z star squared times 126. I'm going to divide both sides by 126. So 450 divided by 126, and that equals 3.5714. 3.5714. And that's going to equal Z star squared. So I'm going to go ahead and take the square root of both sides so I can get Z. So raising that to the half power, that's taking the square root. I end up getting 1.8898. So, and remember when you're taking the square root, we're going to have a plus or minus. So Z is going to equal plus or minus 1.8898. Well, that looks like to me that if I'm drawing a picture of this, we know all Z's are centered on 0. And here's my lower, my negative 1.88. Here's my upper, positive 1.88. And my standard deviation is 1. So let's go do a norm CDF. Lower bound, negative 1.8898. Upper bound, 1.8898. Mean is 0, standard deviation of 1. All right, so second bars, norm CDF, lower bound, negative 1.8898, upper bound, 1.8898. Because basically what we're figuring out is what this shaded area is right there. And we have a 0, 1. And we find out 94.1%. So looks like to me the best answer to 71 is C, 94.1%. All right. Moving on to 72. A survey is to be taken to estimate the proportion of voters who favor stem cell research. Among the following proposed sample sizes, which is the smallest that will guarantee a margin of error at most 0.35 for a 96% confidence interval? All right. So, among the following sample size, which will be, okay. So we're looking for N. And so we're going to go back to the same formula that we just used. N equals Z star squared times P hat times 1 minus P hat over ME squared. Well, they gave us the ME squared. They gave us the ME. It told us the margin of error was 0.35. So we're going to need to square that. Z star, they didn't give us, but we can get it very quickly by doing an inverse norm, second vars, inverse norm, enter, 0.96, keep it centered. And we end up finding that Z star is going to be 2.0537. Oops, I need to keep the red pen. 2.0537. Make sure we square that. Now, when I look at this, I don't see, they did not give me a p hat. So since I don't have that, we're going to have to use the worst case scenario, which is 0.5. So p hat is going to be 0.5, and 1 minus p hat is also going to be 0.5. So let's do some little bit of math here. 2.0357 squared times 0.5 times 0.5. So that takes care of the numerator, divided by 0.35 raised to the 0.5 power. Oh, excuse me. Divided by 0.35 raised to the second power. And I believe I may have an answer that's incorrect there. So I end up, no, that's correct. That's right. So I end up with 8.457. Well, that means really I have to be at 9. Well, the one that's closest to 9 is 30. And I remember what the issue is with this problem. This 0.35 is actually a typo, but I have to round up to the one that's the next, the one I have to round up to the next size always. And then I got to find the one that's larger, as large as 9 or larger, the one that's never go down, right? Never go down. So you're going to go to as large or larger than 9 in this case. All right, 73. Political Action Group wishes to learn the approval rating on the environment. From a past study, they know that they will have to poll 270 people for their desired level of confidence if they want to keep the same confidence interval and have a margin of error of 1/3 the size. How many people will they have to poll? All right. So they know that they have basically this is what their original sample size is. Their original sample size is 270. And they want to have an ME equal to 1/3 of what they originally had. So in this case, we're going to use kind of my special formula that I came up with a few years ago for my students because they struggled with this type of problem. And then basically the formula is 1 over the square root of the new over the original equals change in width. All right. So that's going to be 1 over. Well, I don't know what the new is, but I know the original was 270. And it needs to equal 1/3. Well, right away, I don't like having all the square root business, so let's go ahead and get rid of this. Let's just go ahead and raise everything to the second power. I know that's bad math notation, but it'll work for what we're doing. So now we have 1 over, because 1 squared is 1. The square root drops off, and we just have nu over 270 down here equals, well, 1 squared is 1, and 3 squared is 9. Well, this flips over, and we end up having 270, to make this a double bar, 270 over the nu equals 1 over 9. At that point, I can multiply the diagonals and divide by the third, which is 1. So anyway, we're going to go 270 times 9. And if this had been something other than 1, we'd divide by that. So I'm just going to say divide by 1. And we get 2430. So the answer to 73 is E. 74. A guidance counselor wishes to determine the mean number of changes in academic majors by college students to be within plus or minus 0.1 at a 90% confidence interval. What should be chosen if the standard deviation is known to be 0.45? Well, that's interesting because now we're working with a standard deviation. So that means to me that we're going to be working with a Z star formula, but I'm going to say X bar plus or minus Z star standard deviation divided by the square root of N. So let's see how this plays out, because this is going to play out just a little bit differently than what we had before. So this right here represents my margin of error. Well, if I divide both sides by Z star, then I have margin of error over Z star. And that's gone. And now I have standard deviation over the square root of N equals margin of error over Z star. Well, I can flip both sides, and now my square root is on top. And that gives me the square root of N over the standard deviation equals the margin equals Z star over the margin of error. All right. I hate that square root. So let's get rid of it. Don't hate square roots, but it just makes life easier. So now we have N over standard deviation squared equals Z star squared over ME squared. And I can multiply both sides by standard deviation squared, and this will go away, and I'll end up with this. Now, the reason I went through all of this is I wanted you to see how this related to our prior formula that we used. Because our prior formula was, the only difference was instead of having standard deviation squared, we had P times 1 minus P. And here, this is what we end up with, okay? So we know our standard deviation is 0.45, and then we know our ME is 0.1. So when I plug in, I'm going to have 0.1 squared. And I'm going to go ahead and do standard deviation squared. So that's going to be 0.45 squared. 90%, well, I'm going to need to do an inverse norm. Let's do that real quickly and get a Z star. Second vars, inverse norm, 0.90, keep it centered, mean is 0, standard deviation of 1 for all Z scores. And we get 1.6448. And 1.6448 squared times 0.45 squared divided by 0.1 squared. So we end up with about 54.7. All right. Well, that automatically rounded up, but even if you had 54.1, you would definitely want to round up. You would definitely want to round up to 55. Right. So we ended up with N equals 54.78. So N equals 55. That would be the absolute minimum. If it had been 54.1, we'd still round up to 55. Eli and Drew worked together to collect data to estimate the percentage of their classmates who own a particular brand of shoe. Using the same data, okay, this is important. Eli will construct a 90% confidence interval and Drew will construct a 99% confidence interval. Which of the following statements is true? The midpoints should be the same. All right? The midpoints should be the same. And as the confidence level goes up, the width goes up. All right? So Eli was a 90 and Drew will do a 50, a 99, excuse me. So they're going to have a wide, 99 is going to be wider. So Drew's will be wider than Eli. So this is what we're looking for. Eli's interval will be less than the width of Drew's. All right. So the answer to 75 is going to be D. Sue and Javier are working on a statistics project to estimate the proportion of students at their school who have a pet dog. Sue selects a random sample of 81 students from 2,400 students at their school, and Javier selects a separate random sample of 64. All right. So I'm going to make a little note. S N equals 81 and Javi N equals 64. They both will construct a 90% confidence interval for their estimates. Okay, so their confidence levels are the same. Consider the situation in which the sample proportion for Sue's sample is equal to the sample proportion from Javi's. Which of the following statements correctly describes their interval? Well, I know that as sample size goes up, margin of error goes down. So Sue's is narrower than Javi's, or Javi's is larger than Sue's. Javier's interval will have a greater degree of confidence. No. Sue's interval will have a greater degree of confidence. No. The width of Sue's interval will be the same. No. The width of Sue's interval will be wider. No. 76. The width of Sue's interval will be narrower. All right. It won't be quite as wide as Javi's. All right. 77. A 1993 Los Angeles Times poll of 1,703 adults revealed that only 17% thought the media was doing a very good job. With what degree of confidence can the newspaper say that 17% plus or minus 2% of the adults believe that they were doing a very good job? All right, so we have, in this case, we have an N equal to 1,703. We have a p hat equal to 0.17. And we have a margin of error of 0.02, or 2 divided by 100. So let's go back to that N formula. N equals Z star squared P times 1 minus P over M E squared. So N equals, oh, excuse me, not just N, we can plug in for N this time. So 1,703 equals, we don't know what Z star is, that's what we're looking for. Well, we'll have to find it first, and then we can get our confidence level. 0.17 times 0.83, that's the 1 minus the 0.17, over 0.02 squared. All right, so let's deal with this for the right-hand part first. So 0.17 times 0.83 divided by 0.02 squared. So 352.75. So we have 1,703 Z star squared over, not over, times 352.75. We're going to divide both sides by 352.75. So 1703 divided by 352.75 equals 4.82. And I've kind of run out of room, but we'll say I'll fit it over here. Z star squared equals 4.8277. Take the square root of both sides. I know you're not supposed to show it that way, but I'm doing it quick. So I'm going to raise it to the half power. And I end up getting 2.197. So Z equals plus or minus 2.19772. All right. And if I'm drawing a picture of that, these scores are centered on 0. We have a lower bound and an upper bound, and I'm looking for this area. So I can do a norm CDF. So second vars, norm CDF, lower bound, negative 2.1972, upper bound 2.1972, mean is 0, standard deviation of 1. And I end up with about a 97.2%. So my best answer choice for 77 is D. A politician wants to know what percentage of voters support her position on the issue of forced busing for integration. What size of voter sample should be obtained to determine within 90% confidence to support the level to within 4%? So in this case, they're telling us we want a 90% confidence level because that's going to drive our Z, but our margin of error in this case is 0.04. All right. So we'll go back to our formula. N equals Z star squared P times 1 minus P, P hat times 1 minus P hat over ME squared. All right. So we're looking for N. We know that our margin of error is 0.04. We know we want a, where did it say it? 90%. So I can just go second vars, inverse norm, 0.9, and I get 1.6448. Don't forget to square it, or your margin of error. So those both need to be squared. And this is going to be, I look and there's no P hat. So we have to use the worst case, which gives us our largest standard deviation. This is P, this is 1 minus P. So 1.6448 squared times 0.25. You know what? I won't skip that. 1.6448 squared times 0.5 times 0.5. So that takes care of the numerator, divided by 0.04 squared. And we end up with 422.1 or 422.7. We always round to a whole number and we always round up. So N is 423. If 422 had been given, that would have been wrong. If you left it as 422.7, that's also wrong. All right. Had this been a free response question. Number 79. In a New York Times poll measuring a candidate's popularity, the number of claimed that in 19 of the 20 cases of its poll results should be no more than 3% off in either direction. All right. So the margin of error in this case is 0.03. All right. So they said 19 out of 20. Well, 19 out of 20 means 19 divided by 20, that's 95%. So basically we have a 95% confidence level. All right. What is the confidence level? Well, we just found out that it was 95%. So we know we're dealing with D or E. And they said, what sample size should they use? Well, we're going to go back to our sample size formula. N equals Z star squared P hat times 1 minus P hat over M E squared. Well, since we know our confidence level, we can go to second vars, inverse norm, 0.95, mean zero standard deviation 1, and we end up getting 1.9599. So 1.9599 raised to the second power. P hat in this case, they didn't give us one, so we have to use 0.5, the worst case. And our margin of error is 0.03. Don't forget to square it. So let's do that work. 1.9, I'm gonna clear that, 1.9599 squared times 0.5 times 0.5 divided by 0.03 raised to the second power. And I get 1,067. So my best answer choice is easily 1,068. And notice, if I have any decimal whatsoever, I always have to round up. Okay. All right. Raul will select a random sample of students to create a 95% confidence interval of the following, which is the smallest sample size that will result in a margin of error of no more than 5 percentage points. All right. So they're telling us ME equals 0.05, and they want a 95% confidence level. So N equals Z star squared P hat times 1 minus P hat over M E squared. We know we can plug in, don't forget to square this, 0.05 Z star, second vars, inverse norm, 0.95, and we get 1.9599. And P hat, since they didn't give us to us, we're going to just use 0.5 and 0.5. Second vars, 1.9599 raised to the second power, 1.9599 second power times 0.5 times 0.5, that takes care of the numerator, divided by 0.05 squared, that's the denominator, equals 384.12. Once again, we ended up with the decimal, so we round up, always. All right, that concludes this video. I sure hope it helped. I'll talk to you later. Thank you.